Remember building Legos as a kid, the joy of creation, the thrill of seeing your imagination come to life, one brick at a time? Those moments of pure creativity and fun were just the beginning. Now imagine that, but your creation can move, sense the world, and even learn. Picture a world where your Lego creations aren't just static models, but dynamic, interactive robots that can perform tasks and respond to their environment. Building your own AI robot might sound like science fiction, but it's totally doable, even in your own home. With the advancements in technology, what once seemed like a futuristic dream is now within reach for hobbyists and enthusiasts alike. This isn't about building the Terminator, though that would be cool. Instead, it's about creating small, friendly robots that can bring joy and learning into your everyday life. Imagine a robot that can play games with you, help you with simple tasks, or even keep you company. We're talking about small, fun robots that can teach you about programming, electronics, and mechanics. These educational robots are designed to be accessible and engaging, making the learning process enjoyable and rewarding. Imagine a robot that follows a line, avoids obstacles, or even fetches your slippers. These simple yet fascinating tasks can be the starting point for your journey into the world of robotics. Each project you undertake will build your skills and confidence. The best part? You don't need a fancy lab or a degree in robotics. You can start right in your living room or at your kitchen table. The barrier to entry is lower than ever, thanks to the availability of affordable kits and online resources. With some basic tools, readily available parts, and a healthy dose of curiosity, you can dive into the world of AI and robotics. Whether you're a complete beginner or have some experience, there's always something new to learn and explore. So why wait? Let's get started on this exciting journey together. Okay, let's be real. Building an AI robot from scratch can be challenging, but don't worry, that's part of the fun. It's like solving a puzzle, except this puzzle moves and blinks at you. One of the biggest hurdles might be wrapping your head around the electronics and programming involved, but fear not. There are tons of resources available online, from beginner-friendly tutorials to vibrant communities where you can ask questions and get help. Think of it like learning a new skill, like playing an instrument or speaking a new language. It takes time, patience, and a willingness to experiment. But the rewards? Totally worth it. Now you might be thinking, Adam, this sounds expensive. And yeah, building a robot can cost a bit, depending on how ambitious you are. But it doesn't have to break the bank. Start small. You don't need the latest, most expensive parts. There are plenty of affordable options out there. And you can even repurpose old electronics or toys. Get creative. Remember, the journey is just as important as the destination. Each challenge you overcome, each problem you solve, brings you one step closer to building your very own AI-powered companion. Every robot needs a brain, and that's where Arduino comes in. This small but powerful microcontroller is the heart of many DIY robotics projects. Whether you're building a simple robot to follow a line or a complex machine to perform intricate tasks, Arduino is the go-to choice for hobbyists and professionals alike. Arduino is like a tiny computer that you can program to control your robot's movements and actions. It can read inputs, such as light on a sensor or a finger on a button, and turn them into outputs like activating a motor or turning on an LED. This versatility makes it an essential tool in the world of robotics. Think of it as the conductor of an orchestra, telling each part what to do and when to do it. Just as a conductor brings together different instruments to create a symphony, Arduino coordinates various components to bring your robot to life. Each wire and connection is like a musician, playing its part in the grand performance. Don't let the word programming scare you. While it might seem daunting at first, programming in Arduino is much simpler than you might think. You don't need to be a computer science expert to get started. Arduino uses a simple, beginner-friendly language that's easy to learn. The Arduino IDE, Integrated Development Environment, provides a user-friendly platform where you can write and upload your code. With just a few lines of code, you can make your robot perform basic tasks. There are tons of online tutorials and resources that can guide you through the basics. Websites, forums, and video tutorials offer step-by-step instructions, making it easy to follow along and learn at your own pace. You can find projects ranging from simple to advanced, allowing you to grow your skills gradually. You'll be amazed at how quickly you can go from blinking an LED light to controlling motors and sensors with just a few lines of code. As you gain confidence, you can start experimenting with more complex projects, adding new components and functionalities to your robot. It's like magic, but with more wires. The possibilities are endless with Arduino. From simple automation tasks to sophisticated robotics, Arduino opens up a world of creativity and innovation. So, dive in, explore, and let your imagination run wild as you bring your robotic creations to life. Section 5. Scratch, teaching your robot to think. Now that your robot has a brain, it's time to teach it how to think. That's where Scratch comes in. Scratch is a visual programming language developed by MIT that makes coding fun and accessible for everyone. Instead of writing lines of code, you connect colorful blocks like puzzle pieces to create programs. It's an intuitive and engaging way to learn the fundamental concepts of programming. With Scratch, you can program your robot to respond to sensors, make decisions, and even learn from its environment. You can teach it to follow a line, avoid obstacles, or even dance to your favorite music. Section 6. Getting your hands dirty. Building the body. This is the stage where your ideas start to take physical form. It's the moment when your vision begins to materialize, and you can see the fruits of your planning and design efforts. This is where the real fun begins. The excitement of seeing your robot come together piece by piece is unparalleled. Each component you add brings you one step closer to a functioning machine. Building the body of your robot is like bringing a creature to life. It's a process filled with anticipation and creativity. You start with a pile of parts, and through your effort and ingenuity, you create something that moves and interacts. You get to choose its shape, its size, its features. The possibilities are endless. Whether you want a sleek, futuristic design or a more rugged, industrial look, the choice is yours. Each decision you make adds to the personality and functionality of your robot. You can use a variety of materials from cardboard and plastic to metal and 3D printed parts. Each material has its own advantages and can be chosen based on the specific needs of your project. Cardboard is great for quick prototypes, while metal offers durability. Get creative and let your imagination run wild. Sketch out your ideas, experiment with different shapes and configurations. This is your chance to innovate and push the boundaries of what's possible. There are no right or wrong answers here. Every experiment, every trial and error brings you closer to the perfect design. Embrace the process and enjoy the journey of discovery. Remember those Legos we talked about earlier? They were just the beginning. Now you're applying those same principles on a much larger and more complex scale. This is like that, but with a purpose. You're not just building for fun. You're building something that will perform tasks, solve problems, and maybe even change the world. You're not just building something that looks cool. You're building a machine that can move, sense, and interact with the world. Each sensor, each motor, each piece of code you add brings your robot closer to life. It's a blend of art and science, creativity and engineering. Testing is a crucial part of the process. You'll need to see how your robot performs in different environments and situations. This is where you fine-tune its abilities and ensure it can handle the tasks you designed it for. Collaboration can also play a big role. Working with others can bring new ideas and perspectives, helping you to refine and improve your design. Don't be afraid to ask for feedback and incorporate suggestions. Documenting your build process is also important. Keep a log of your progress. Note down any challenges you face and how you overcome them. This can be invaluable for future projects and for sharing your knowledge with others. And finally, celebrate your successes. Each milestone you reach is a testament to your hard work and creativity. Enjoy the moment when your robot performs its first task and take pride in what you've accomplished. Section 7. The moment of truth. Turning it on. You've spent hours, days, maybe even weeks building your robot. You've connected the wires, written the code, and assembled the body. Now, it's time for the moment of truth, turning it on for the first time. There's a sense of anticipation, a mix of excitement and nervousness as you flip the switch. Will it work? Did you connect everything correctly? Did you miss a line of code? And then, it happens. The motors whir to life, the sensors blink. Your robot moves, hesitant at first, then with growing confidence, it's alive! Section 8. Debugging. Every robot's got 'em. Let's be real, things don't always go according to plan. You might turn on your robot and nothing. Or worse, it might move in the opposite direction you intended. Don't panic, this is all part of the process. Debugging is a natural part of building anything, especially robots. It's like solving a mystery, tracing back your steps, checking your connections, and scrutinizing your code. The good news, Every problem you solve, every bug you fix, makes you a better builder, a better programmer, a better problem solver. It's all part of the learning process. Section 9. Show off your creation. You've done it. You've built your own AI robot, and it works. Now it's time to show it off to the world. Share your creation with friends, family, and the online community. Post pictures and videos of your robot in action. Explain how you built it, the challenges you faced, and the solutions you found. Inspire others to embark on their own robotic adventures. Who knows? You might just spark a passion for robotics in someone else. You might be the reason why some kid, somewhere, decides to pursue a career in STEM. Section 10. The future is now, you can build it. Building your own AI robot might seem like something out of a science fiction movie, but the truth is, the future is now. With a little curiosity, a lot of patience, and the right tools, anyone can build amazing things. Don't be afraid to experiment, to make mistakes, to learn from your failures. That's how innovation happens. That's how we push the boundaries of what's possible. So what are you waiting for? Grab some tools, fire up your computer, and start building. The world of robotics is waiting for you.